Hello, this is Miss Moreland. Welcome to our second video of Unit 4. It's 7.3. We're going to focus on the product properties or multiplying properties. So our first property is a to the m times a to the n. Now, we're multiplying two of the same bases. In order for this rule to work, you have to have the same base. So if I'm multiplying two of the same bases, I actually add the exponents. So it'd be a to the m plus n. Okay, when I raise a power to a power, meaning there's a parenthesis, a to the m raised to another power of n, that's when I multiply the exponent. So it would be a to the m times n. And then we have product of a power of a product, meaning if I have two things multiplied together and they're both raised to the n, it's like you're distributing that exponent to both parts. So it's going to be the same thing as a to the n times b to the n. Right, so now we're going to jump into some examples. Just a quick note, numbers are still numbers, so I'm not going to be adding 3 and 4 because they're not exponents. I only add the exponents. So when I do this, I still do 3 times 4 and I get 12. But when I do x to the second times x to the third, I get x to the fifth, because when I multiply the same base, I add the exponents. But note, numbers are still normal numbers. Multiply them like you always do. Right, so this one I have an exponent with negative 3 times x raised to the second. So it's like I'm raising negative 3 to the x and x, or negative 3 to the second and x to the second. Now I always want to simplify the numbers, so negative 3 squared is really the same thing as 9, and x to the second can't be simplified, so I get 9x squared. Alright, so another one outside, I need to distribute that, but notice when I go to distribute it, I have something to the 0 power. And remember, that's kind of like it goes away. That's really just a 1. So I'm just going to cross that out. We don't really need that. So we get x to the negative 6. And again, if we were to distribute the 3 to the 0, it would be 0 still. So that's still 1. So again, our answers can never include negative exponents. So when we have a negative on top, we move it to the bottom. Right, so the next one, I'm going to multiply my exponents because it's a power raised to a power. So my first step is I get x to the negative 2. Remember, answers cannot include negatives, so I need to put 1 over x squared, and that's how I get my final answer. This one looks like it has a lot going on, but it's not as bad as it looks. So first I'm going to distribute the 5 to both of those, and over here I'm going to multiply the exponents. So I should end up with a to the 2 times 5, which is 10, b to the 2 times 5, which is b to the 10th, and I'm still multiplying that by a to the third raised to second. Remember, when it's power to a power, I multiply, so I get a to the 6th. Now I have two of the same bases. I have a to the 10th times a to the 6th. When I have the same bases being multiplied, I add the exponents, so I get a to the 16th. And I don't have any other bases of b, so I get b to the 10th. Right, over here I'm just going to multiply those because it's a power raised to a power. And what's nice about this is it looks like I'm going to have a messy problem because I have negative exponents. But negative 2 times negative 4 actually turns in x to the positive 8. And I can leave my answer just like that because it canceled out the negatives. Right, our last two examples. Again, power to a power means I multiply. So I'm going to do that twice. So I get a to the negative 12, because negative 3 times 4 is 12. And I get a to the 14th. Still multiplying. Now here's the trick though, I have two of the same bases. When I multiply the bases, I add the exponents. So, mind my writing here, I don't really have much. So I add the exponents when I multiply two of the same bases. So when I do negative 12 plus 14, that leaves me with positive 2, so I get a to the second. Right, again, this one, I have two bases here. I have an a and I have a b, so I'm going to get a to the second. Because I originally, whenever you don't have something there, it's beneficial sometimes to write a 1. Because whenever there's nothing there, it doesn't mean it's a 0, it means it's a to the first. So that would give me 2 times 1, which is why I got a to the second. And then it's b to the 3 times 2, which is b to the 6th. I have no negative exponents, notice, so I can leave my answer just like that. Alright, try the on your own tonight, and I will see you tomorrow in class.